In question 12, you're shown a graph and you're told that this is the graph of 3x plus 2y equals 12. And then you're asked to do a few things. Basically complete the table. The table you had, looked like this. X and y, 0, 1 and 2 on the x-axis, and you were given 2 on the y. Now we're completing it for y equals 3 times x minus 1. So each x value, I'm going to times by 3 and minus 1. 0 times 3 is 0, minus 1 is minus 1. 2 times 3 is 6, minus 1 is 5. So minus 1, 2 and 5. So these are all coordinates which lie on this line. So then it said, draw the graph of y equals 3x minus 1 on the grid. So you needed to plot these points. 0, I've not given you enough space. Silly me. 0 minus 1 would have been down here. So you should have seen a cross down at minus 1. And 1 and 2 would have been here. And 2 and 5 would have been up here. Okay. Now what a lot of you did was you just drew a line all the way through. So like this. Okay, all the way down to minus 1. Now, the problem with that is you haven't taken into account the domain. So the domain says x is only between 0 and 2. So if I were to sketch it here, 0 it crossed at minus 1 and 2 it crossed at 5. So you should have seen shaded in dots at 0 and 2 because those are the endpoints. And then the line joining them in between. We're only interested in this domain. So you need to see dot there, shaded dot there, and then nothing either side of it. So a lot of you lost a mark there because you just drew the line fully. Think about what domain you're looking at. It then says use the graph to find the solution to this pair of simultaneous equations. Now if you look at the equations given, this one is the same as the one that was already drawn on the graph, and the second one is the one that we draw on the graph. So if you think about the word simultaneous, it means two things are the same. So where on this graph are these two lines the same? Well, it's going to be at this point here. So yours would have been more accurate than mine. But what's the value of the x and y coordinates there? Well, the x coordinate is roughly 1.6. Okay, and your y coordinate roughly 3.6. So if you'd done it accurately, you would have got a more exact answer than me. So using a graph, simultaneous equations, you need to look where they intersect. The final part of this question said, now do the same thing, find the exact solutions using algebra. So same equations, using algebra to find the solutions. Right. In this instance, different ways of solving simultaneous equations. If I'm given y as the subject, I'm just going to substitute this in for y into the first equation. So I get 3x plus 2 lots of 3x minus 1 is equal to 12. And then if I expand this, I get 3x plus 6x minus 2 equals 12. So collect the like terms, I get 9x equals, and put the 2 across, 14. So x equals 14 over 9. So a lot of people got there and then got a bit stuck. So how do I find the y? Well, I need to substitute that back into this equation to find out what y equals. Okay, so it would look, let's write it down here. Y equals 3 lots of x, well we know x is 14 over 9, minus 1. Now here, I can simplify, I could just multiply across 3 times 14 divided by 9, but I can see that 3 and 9 have got a common factor of 3, so I'm going to divide them both by 3. 1 and 3. So my equation now becomes 14 over 3 minus 1. Okay, how do I do 14 over 3 minus 1? Well, if I want to subtract fractions, I need them to have the same denominator. So 14 over 3 minus something over 3. I want 1 to be written as something over 3. So what divided by 3 makes 1? 3. Anything divided by itself makes 1. So I get 14 over 3, take away 3 over 3. 14 take away 3, it's 11. So I end up with 11 thirds, 11 over 3. So two solutions, x is 14 over 9 and y is 11 over 3.